So today we're going to take a look at the eye and how the eye works. It's a little bit different. This is kind of a nice blend between biology and physics. The biology obviously being the fact that in this case you're dealing with an organ in your body, and the physics being with we're going to be dealing with a lens because your eye does have a lens in it. So let's take a look at the parts of the eye as well first. I'm going to zoom out a little bit so you can see it. Um, so in this diagram, you can see all the different parts of the eye. So let's focus on the physics part first. You can see that you do have a lens. And if you take a look at this lens, you're going to notice that it's actually a concave or a converging lens. So that means that light is going to enter in and it's going to converge on the back of your eye. How does light enter in? Light enters in through this hole, the pupil. So you can see that you've got the pupil here, this hole. And on either side of the pupil here, you have what's called the iris. The iris is that color part of your eye. Over top, so you just don't have a giant hole in your eyeball. Over top, you can see that you've got something called your cornea. So your cornea is like a thin but a clear piece that goes over top of your lens. To make sure that your cornea doesn't come in contact with your iris, it's actually filled with a liquid. So you can see this bulge is filled with a liquid. We call this liquid aqueous humor. And then down here, these are actually some of the muscles that'll help to change the shape of the lens, change the shape of the cornea, and cause your eye to focus. In the back of your eye, your eyeball is actually filled with a liquid as well too. That liquid is called a vitreous humor. You have what's called a sclera. It's a very thick muscular background on your eye. You have two layers. You have what's called the choroid layer, and then you also have what's called the retina. So the retina, we're going to talk about this in detail in a second. The retina actually contains the cells that allow you to see. You also have something called a blind spot. So if you take a look, your retina is this red layer here. That's what allows you to see. Your retina goes through the back of your eye, but back here, there's no retina. That's because the optic nerve has to exit your eyeball. The optic nerve has all the data from what your eye is seeing, and it brings it to your brain. So since the optic nerve has to enter the back of your eyeball, there's no retina there. So you do have what's called a blind spot on your eye. So this is what your eyeball looks like. Now let's take a look in detail at some of these parts. Let's start with the iris. So the iris is this part of your eye. Again, it's the colored part of your eye, and it's going to help to open or close that central hole, and that central hole is called the pupil. So the pupil controls how much light gets in and out of your eye. So you've got your central hole here, your iris, which is all different colors depending on your eye color, and it's going to act to open or close your pupil. So sometimes your pupil might look really big. That's because your iris is dilated. Sometimes it's going to look really small. That's because your iris is contracted. Let's now deal with the pupil. The pupil just appears black. It's actually black because it's a hole. So it's not actually black in color. There's no color there. There's actually a hole, and that hole is leading into your eyeball. It's going to allow light to pass onto the lens. After that, we have the cornea and the lens. So let's take a look at the cornea first. The cornea, again, is this outer flap. It's a transparent bulge on top of the pupil, and the cornea is actually going to help to focus light. So when light actually enters in, light is going to slightly focus as it travels through the cornea. That means it's going to slightly converge. So that light is going to slightly converge, and it's going to converge right onto the lens. So the cornea acts to converge light onto the lens. The lens here is going to cause light to converge even more. That light is going to converge, and it's going to converge into one spot, and this spot is where the image is going to form. So notice this spot is converging right on the back of your eyeball. This is where the image is going to be, and this is what's going to allow you to see. Let's talk a little bit about how light refracts. Light refracts through the cornea, then through the lens. So it's actually refracting twice. So it's actually bending through the cornea first. It bends the most through the lens, and then you're actually going to see that light is spread over the back of your eyeball. We actually have color receptors. We're going to talk about this in a second. So we're able to actually pick up colors, so we can see all different colors. Not all animals can see in color, depending on what type of receptors they have. Let's talk a little bit more about the retina. So if you were going to zoom in with the camera on the back of your retina, it would look like this. Notice there are lots of blood vessels on the retina. The retina is made up of cells, so it does need blood vessels. The retina is a light sensitive region at the back of your eye, and that's going to transmit the image to your brain. So the image is actually projected onto the retina, and then the retina is able to translate that image into an electrical signal, and that electrical signal travels to your brain. The retina has two different cells on it. It has rods on it and it has cones. So the two types of cells on a retina are rods and cones. Rods are sensitive to dim light. So those rods are what allow you to kind of see in the dark. And I understand you don't have great vision in the dark, but you're able to adjust to a darker room or a darker space, and you're able to actually see images. So your rods are what allow you to see in dim light or the dark. Your cones are the bright light, and our cones are actually sensitive to color. So some animals actually just have rods, so they can only see things in dim light. And some animals have cones, but they don't have all types of cones, so they're not able to see all colors. So we have all types of cones, so we can see both bright lights and we can see colors. There's three types of cones. There's red, there's blue, and there's green. So as humans, we have all three types of cones. These three colors can be combined to form all colors. So since these three colors can be combined to form all colors, we're able to see all colors. This isn't true for all animals. So for example, dogs only have one type of cone. Primates actually do have three types of cones. There's some types of cats that have two types of cones. So humans and primates are the only two animals that are considered to see in color. Every other animal sees in either limited or no color based on the number of cones that they have. How does the retina actually work? The retina is going to convert that light into an electrical signal. That electrical signal is then transferred to the brain. So remember, we talked about this a little bit in biology when we talked about the fact that you think in electricity. So any thought that leaves your brain is actually an electrical signal. That means that any thought going into your brain is also an electrical signal. So the retina actually is converting this light to an electrical signal, and that electrical signal is transferring down your optical nerve. So that optic nerve is coming out right at the back of your eyeball, and it's attached to your retina. Because your optic nerve is not covered in the retina, so the retina's here, but the optic nerve causes a gap in the retina, you have something that's called a blind spot. That means if an image is focused directly on this spot, there's no light cells, there's no retina cells to pick it up, so therefore you're not going to see the image. So your blind spot is a spot at the back of your eye where your optic nerve is located. Since there's no retina at this point, no image that forms on that spot will be seen. You don't notice your blind spot because you have two eyes. So your right eye's blind spot, whatever's in your right eye's blind spot can be seen by your left eye, and whatever's in your left eye's blind spot can be seen by your right eye. So since humans have two eyes, we're able to kind of make up for that blind spot and vice versa. Also, since humans have two eyes, this is what allows us to have a little bit of depth perception. So we're actually seeing two different images. Our brain is then stacking these images on top of each other, and it's what allows you to see depth perception and accurately reach for something and actually know how far that object is. How we actually see. So your eye is a lens. Since your eye is a lens, it's going to act like a lens, and your image is actually going to look different. So again, remember your eye is a converging lens. Know that all converging lenses, based off our diagrams, produce inverted images. If we actually look at the salt for the lens in your eye, the images are actually going to be inverted. They're going to be smaller and they're going to be real. So essentially, everything that you see, everything that gets projected onto your eye is actually upside down. So why are you not seeing the world upside down? You're not seeing the world upside down because your brain knows this, and your brain flips that signal back right side up. So the image, the actual picture that reaches your brain is everything upside down, but your brain knows this, so it actually is really smart. It goes ahead and it flips that image so that way you perceive everything to be right side up. Let's talk a little bit about these ciliary muscles now. These ciliary muscles are responsible for, we call it accommodation. Accommodation just means changing the shape of the lens. So your ciliary muscles are going to allow you to change the shape of the lens. This is going to allow you to change the focal length and focus the image on the retina. So depending if you're looking at something really close up or really far away, your focal point is going to have to be slightly different. It's going to have to change. It's going to go through these accommodations. So some people are really good at changing their focal point with their ciliary muscles. Some people aren't great at this, so they need glasses to help them with this. So you can actually kind of see your ciliary muscles working if you focus on a really far away image and then quickly go to a close image. You can actually see almost like a moment of blurriness as your ciliary muscles actually work to accommodate that focal length. So a healthy eye that has healthy accommodations can see both distant and nearby objects. So what about people that are not able to see or are considered to have not necessarily an unhealthy eye, but just aren't as good at these accommodations? We're going to look at the different conditions under which you might need glasses. So the first condition is called hyperopia. It's another term for farsightedness. So if you know that you're farsighted, this is what you have. What farsighted means is that you can see distant objects really well. You're not great with seeing nearby ones. So you can see anything really far away clearly, but when you look up close, it looks like it's blurry. What is actually happening here is the distance between your lens and your retina is too small. So we actually call this a short eyeball. So the distance between your lens and your retina is too small. So what happens is when your image actually comes in, it focuses behind the retina. So remember, where the image is focused, that's your clearest image. So where your clearest image is actually being projected, it's behind your retina. Your retina is actually picking up a still slightly blurry vision. In order to correct that, I do have this. In order to correct that, all we want to do is we want to cause light to focus a little bit when it enters the eye. So normally it's too far away. So if we can cause light to focus a little bit more first, going through a lens, and then it'll focus again going through the cornea, then it'll focus again going through the lens in your eyeball, it's going to end up projecting on the right spot. So anyone that has farsightedness, they're going to have a converging lens that's going to help them to concentrate the light in a little bit more, and it's going to cause the light to focus on the proper spot. So they're going to use a converging lens to help to bend or refract the light on the retina. It's also called a positive meniscus lens. So if you actually know what your prescription is from your optometrist, if you have a positive meniscus lens, you are farsighted, you have a converging lens. Let's look at presbyopia now. Presbyopia is what happens when your eye lens is going to lose elasticity, resulting from the loss of accommodation as a person gets older. So translation, essentially, as your eyes get older, we get worse at accommodating them. So your lens has some elasticity in it. That elasticity fades over time. So the older you get, the less elastic your eye is, the harder it is for it to focus. So oftentimes when you're older, you can't read small print as easily when you were younger. So you might have, your parents might have, they call them sometimes cheater glasses or reading glasses. These are glasses that aren't even necessarily a prescription. You can literally just buy them from the dollar store, and they're going to allow light to focus in a little bit more, and they're going to allow you to see things clearer. So it doesn't mean that your eye's unhealthy. It just means that as we get older, we naturally lose that elasticity. So it's not due to an eyeball being too short. So the eyeball is actually a perfect length. So it's also corrected using that converging lens or those cheater glasses. All right, the last kind of fault with an eyeball is myopia. Myopia is nearsightedness. So if you're nearsighted, you can see nearby objects, no problem, but you have a harder time with objects far away. This is actually me. I can't see objects far away as well, and I have a harder time in dim light. So oftentimes I'll use my glasses for driving at night so I can see road signs and things like that. What happens with someone that is nearsighted? The distance between their lens and the retina is actually too large. So we call this a long eyeball. Since it's too large, what's happening is the light isn't focusing enough. So the light is actually focusing in front of the retina. And then afterwards, you're still getting a blurry image. So the ideal focus, the ideal part to read the image would be here. Unfortunately, in a long eyeball, the retina is not all the way until back here. So you're getting a bit of a blurry image. So therefore, objects that are far away are going to appear blurrier than those that are close. So how to correct this is you're going to use a diverging lens. So you're going to cause that light to spread out just a little tiny bit, and then it's going to converge through the cornea. It's going to converge again through the lens, and it's going to go ahead and focus on the proper spot right on the retina here. This is also called the negative meniscus. So again, if you know what your prescription is and you have a negative meniscus prescription, it means that you are farsighted. It means you're nearsighted. It means that you have a harder time seeing far away objects. Last little bit that I want to talk about is laser surgery. If you've been through laser surgery, or you know someone that's been through laser surgery, what laser surgery is you actually reshape the cornea. So they're going to go in, actually reshape your cornea using a laser, and that's going to correct the refractive defect in your eye. So it's going to either cause light to bend more or bend less, depending if you're near or farsighted. It's really effective in most cases. So most people have an effective laser surgery. It does pose some risk though. So there is a risk of infection or a risk of maybe doing damage to the eyeball. And sometimes laser eye surgery can lead to poor night vision. So that's the eye. So that's a nice little view of how biology and physics can actually come together and do some pretty amazing things, which is allow you to see.